Now I think that we can start the talks. And the first one is by Michele Emmer, Università di Roma, La Sapienza. He has realized 18 movies on arts and mathematics. He organized international exhibits, part of the section Spazio at Biennale di Venezia in 1986, the first exhibit by Escher in Italy in 1986. He's the main organizer of the conference Matematica e Cultura in Venezia. He has published more than 1,000 articles in the last 25 years. Mr. Emmer?
In any case, I'm very glad to be here, and particularly here to the Morandini Foundation. And art and mathematics means almost everything. So I will give you just one little known example. And this is the reason why there is written for 46, 47. This is after the Second World War. So the next slide. So this involved 4 people. The first one is Max Bill, in alphabetic order, Corrado Cagli, Donald Coxeter, and Charles Olson, the first one of the well-known artists of the 20th century. Corrado Cagli, a very famous Italian painter. Donald Coxeter, a classical geometer. He was British, but morally Canadian. Charles Olson is a poet, US poet. And here they are. On your left is Max Bill. Then you see Charles Olson. On the right, Corrado Cagli. In color, Donald Coxeter. Donald for friends, because his name was so long, it was better to call him Donald. So the history started in 1923 when Donald Coxeter began his work on geometry, Euclidean geometry, in more than 3 dimensions. And he wrote and published a book, Regular Polytopes, in 47, 48. Well, first edition 47 and second in 48. He wrote, only 1 or 2 people have attained the ability to visualize hypersolid as simply and natural as we ordinary mortals visualize solids. But a certain facility in that direction may be acquired by contemplating the analogy between 1 and 2 dimensions, then 2 and 3, and so 3 and 4. I will not speak about Flatland, one of my favorite topics. This is the cover of the second edition of the book in 1963. A few words about Cagli and Olson. At the end of the Second World War, the research of Poincaré on topology and the publication of the Coxeter book on polytopes interested an Italian painter living in the USA and a US poet. They will imagine a sort of synthesis between Euclidean and Euclidean geometries, multidimensional space, and topology. And this is one of the drawings of Corrado Cagli. I will leave all the words as they are written for the work of artwork. So this was written in Italian, maybe it's written in this way, etc. 46. And this is the poem, the beginning of the poem of Charles Olson. Upon a Mobius strip, materials and the weight of pain, their harmony, a man within himself upon an empty ground. His head lay heavy on a huge right hand, itself a leopard on his left and angled shoulder. I will show you all the text in a few moments. The poems were written in the same year, November 46, and then was part of the 3 exhibition in Paris, in New York, and then in Cagli, when Cagli was already back to Italy. So Corrado Cagli was an Italian artist interested in topological surfaces like the Mobius strip, and in 46 he made a drawing that you already saw and a painting that I will show you in a few moments. His interest in the Mobius strip in Euclidean geometry in the 4th spatial dimension arose exactly from the discovery of Coxeter's book. Even in non-Euclidean geometry, the four-dimensional topology and the Mobius strip are not completely interrelated topics. But the very interesting thing for the artist was the idea of space. So this is the painting of Corrado Cagli in 47. In Italian, the title, A Mobius to Mobius. This is oil on canvas. Coxeter. A polytope is a geometrical figure bounded by portion of line, planes, and hyperplane. In 2 dimensions is a polygon, in 3 dimensions a polyhedron. The word polytopes seems to have been, always word of Coxeter, coined by Hoppe in 1882 and introduced in English by Mrs. Todd 20 years later. But the concept under the name of polyscheme goes back to Schlafly, who completed his monograph in 1852. This is always the book of Coxeter. This is to say that this was, in some sense, an old subject of mathematics, not a recent subject for 47, 48. This is the, in the book of Coxeter, the 6 polytopes, regular polytopes in 4 dimensions. The last one is the 100 cell, 120 cell. This is the picture. See. So this is the table, and this is the devo coordinare ancora bene. So this is an image, and I will show you in a moment who produced this image, who is also in the book of Coxeter. This is very most well known, the hypercube, the divine cube in 4 dimensions, as told by the square in Flatland. So when Coxeter book came out, Cagli was in the USA, and he will go back to Italy in 48. He arrived in USA in the 40s, after having fled from Italy at the advent of the racial laws in 1938. And he became part of the community, of the artist community in the United States. Enlisted as a volunteer in the war, participated in Normandy invasion, and in all the battles in the half of Europe, until the liberation of Buchenwald camp in April 45. He was there. And we'll bring back a series of drawings based on what he saw in the concentration camp. I will show you just one. All the drawings has no title. In 47, with the I want to look at just a few moments to the drawing. So in 47, he discovered the 4 dimension, the Mobius strip, etc. And the Mobius strip was invented in 1848. And the book of Poincaré was printed in 1898. So many, many years before. In Cagli, the interest of Cagli in topology, the Mobius strip, the 4 dimension, etc., was very profound in him, and he suggested Olson to read the Coxeter book. They discussed the Mobius strip and also asked Cagli to collaborate with his drawings in the publication of a small book in which he will insert some of his poems. Among this, the Mobius band. This book is Y and X, 5 poems by Olson, 5 drawings by Cagli. This is the cover of the original first print of the book. See. And this is, I will not read it, the text of all the poems of Charles Olson. And these are 2 of the drawings of Corrado Cagli inserted in here. Now it's complicated to show you the first drawing of Corrado Cagli, and you will see some similarity in the shape of the form. And this is the other one. Also, the titles are exactly in the language that he used. The first attempt to make his poetry for also the space field occurs exactly with the Mobius strip. Also translated the distortion taking place when projecting language onto a hypothetical Mobius strip. The distortion and movement are intended to force language to do a like job in its dimension as a painter would operating on a strip. So there was strict cooperation between Charles Olson and Corrado Cagli. And the equivalence between Olson poetry and Cagli's drawing is recognized by the painter himself, who said, it seems to me that there is something very mysterious going on in the field of dimension. Drawings turn out to be poems, and poems bring back sudden changes to the source of the drawings. I will not read all the thing. Of course, there is a quotation of the analogy, is always the same word of Coxeter, etc., etc. The resulting image seems to describe a field of opposing forces in constant tension. Then this reflection, where the center of the Italian painted activity, is also indicated by the works presented the following year, 48, in his personal exhibition in Rome, La Galleria del Secolo, with the title Four-Dimensional Drawings. As himself told in his essay, in the catalogue, for the creation of this work, the artist was inspired by a four-dimensional solid of the self-made mathematician Paul Samuel Donkian. He has his studio in Hartford, Connecticut. Cagli went to Cagli went to Hartford. This is probably Donkian. It's not clear. I have asked also the wife of Donald. Probably is Donkian, with the 120 cell. Why he made this, all this? For exhibition. And this is the exhibition that they construct for the 40s, and they show in several places in the United States. And then they were all located in Hartford, where Coxeter went, Cagli went to see them. And in the center, you will see the 120 cell. Here again, with the classification of the polytopes down in the picture. This is the drawings that Cagli made of the, I'll go back just very quickly, of the exhibition. And the title is, in Italian, Strumenti at Hartford, 47. And this is the interpretation of Cagli of the four dimension in his work. This is the catalogue of the exhibition in Rome. And these are two examples of drawings in the book. There was at the exhibition in Rome. There is another point very important. In defining a new idea of space, Olson declared the ethical use that this exploration assumed for him. The new conception of space goes towards a new art, which goes toward a new man and woman, and towards a new humanity. And this is very interesting because at the end of the 19th century, the beginning of the 20th century, the influence of the idea of four-dimensional, spatial four-dimension, not time, influenced many, many people, especially in Russia, including Uspensky and then very well-known Florensky. A few years was both mathematician and a priest. Well. This is the latter painting that Corrado Cagli made in 47, where you will recognize many of the drawings that he made before, including, yes, the Mobius band, but also the cello and other things. Now, what happens also? Max Bill. These are words by Max Bill. I had thought about topological problems. I developed a sort of logical form from this. There were two reasons I continued to be attracted by this particular theme. The idea of infinite surface that is never less finite. There is this idea of infinite finite. The possibility of developing surface that becoming, because of intrinsic laws, led almost inevitably to a formation that proves the existence of aesthetic reality. But both 1 and 2 also indicated another direction. If non-oriented topological structure existed only in virtue of their aesthetic reality, then, despite their exactitude, I would never been satisfied. I am convinced that the foundation of their effectiveness lies in part in their symbolic value, They are models for reflection and contemplation. And these are also words of Max Biel. We say, I am convinced that it's possible to develop an art on a mathematical line of approach, but I will not read all the text. But I show you the very famous endless ribbon of Max Biel, presented for the first time in marble, very large. It's 1 meter, 1.5 meters, and large two, in 1936. When he made this model, this sculpture, he was not aware of the Mobius band. This is what is said. It seems a little bit strange because he studied architecture and design, and it was at the Bauhaus. But in any case, he made a very famous paper for Springer calendar, explaining all the story. And it was important for in the group of concrete art of this period. They made many different shape and form of this endless ribbon. And this is what he explained by a mathematical approach to art, and what is not. It is hardly to say, I do not mean any fanciful ideas for turning out art by some ingenious system already reckoning with the aid of mathematical formulas. It is not it. And the reason why, just the first 3 lines. The last 3, since the time when mathematics was the foundation of all form of artistic expression and the covert link between culture and cosmos, conceivably deteriorated in time. So this is the main reason why you look to mathematics. This is Max Biel explaining with his hands how he invented his endless ribbon in 1936. So this is Max Biel explaining, and I have, but there is not the time to show you the 2 minutes of Max Biel making this shape, and many others. So I'll show you just 2 more images of. There was a Palazzo Reale of Milan 6-7 years ago, large exhibition, Palazzo Reale, of the work of Max Biel, and there was a room called Topological Room. It was his sort of dream. His idea was to have at the British Museum, inside the British Museum, a room on topological surfaces. His topological surfaces. And this is the other. So in 1949, Max Biel wrote a very famous article, The Mathematical Way of Thinking in the Visual Art. The Mathematical Way of Thinking in the Visual Art of Our Time. And I read just the first 2 lines. It must not be supposed that an art based on the principle of mathematics, such I have admitted, is in any sense the same thing as a plastic or pictorial interpretation of the latter. Indeed, it employs virtually none of the research implicit in the term pure mathematics, etc., etc. In 1993, Max Biel made a sort of edited the old paper and with small changes, and it was edited again in English in 1992. I will show the book you. A few years later, there was not really anymore the interest of the artist in 4 dimension. With the exception of Salvador Dalí, in 1954, he made a very famous Corpus Supercubus, which is at the Metropolitan Museum in New York. And there was, I will explain you why it's also important with this story, this painting. And at Biennale of Venice in 1986, here you will see there was a room dedicated to art and mathematics. There were the computer animation of Thomas Banchoff and Richard Strauss. It was the first animation of the hypercube ever made. And the works of Max Bill. And in 1992, there was the first meeting on visual mathematics at the MSRI in Berkeley. And it was published exactly the same week, a special issue of Leonardo MIT Press by the title Visual Mathematics. It was the 50th anniversary of Piero della Francesca's death and also discovery of America. And the cover of this book was two work of Max Bill, and the new edition of the old paper in 49 was published again in this book. This is the cover of the book with the work of Eccolo. With this is the front cover. There is another one on the other cover by Max Bill. Well, I am also at the end of my presentation, and I will end with two things very important. First one, for me, is something that I will never forget. And the second one is a sort of reflection of a collection of the things I have tried to say in this half an hour. I will read every word of this. Corrado Cagli died in Rome on March 28, 1976. In 1978, I have visited an exhibition of his works and was struck by the entitled painting that you saw before 47, which was accompanied the catalog by Charles Olson poem on the Mobius Strip. At the time, I have started making my film on the surface of Mobius with Max Bill, and then I found the Calvi studio and made an appointment to go and film the painting I have seen. The studio was in Rome, in Via della Fonte del Fauno, near Circo Massimo, and is now the headquarters of the Cagli Foundation. I remember the day very well. It was March 16, 1978. When I entered the atelier, I was informed that Aldo Moro, president of the Christian Democrats, several times minister and prime minister of the Italian government, has been kidnapped by the Red Brigade. He will be killed on May 9, 1978, one of the great tragedies of the Italian Republic. The same day. And I will finish with the church. This church, a Romanic church, 11th century, in the center of Italy, Frasassi, the Marche, very beautiful. There is almost nothing inside with the style of the period. Just one little engraving. On the door of the church, there is something there. There is something there. You see, there is something there. And this. This is 11th century in Frasassi, Marche, in a Romanic church. What is this? Well, the church is called the Church of Infinity. The lake that is there is called the Lake of Infinity. There are terms and everything is written of infinity. The symbol of infinity, Wallis, is 1665, more or less. The Mobius band is 200 years later. So what it is not clear. It seems to be three-dimensional, but it's not clear what the interpretation of this. But just to end with this image, to say the connection between art and mathematics, with mathematics and culture, is not really a connection. Mathematics is part of our culture, it's not something separate. It's very long, it's part of all the history of humanity. Saying humanity, you include men and women. Thank you.